So let's try to figure out what this means. When we talk about time slowing down the faster you go, the way that this is usually explained is with a concept called a light clock. And so this is an imaginary structure. It's composed of two mirrors, two reflective surfaces, again, because I can't say that word. And there's a photon, a particle of light, and it bounces in between these two reflective surfaces. And if you knew the distance between the two reflective surfaces, the distance of oscillation, right? You know what the speed of light is. You could, in principle, construct a clock of sorts if you knew some conversion factor. If you use the distance between the two surfaces to create a conversion factor between the number of ticks on the clock and, say, 1 second. Okay, this seems very convoluted and very in the bushes, but just hear us out here for a minute. And actually, in principle, that would make a really good clock, because as the light clock ticks off, right, the photon that's bouncing between the two reflective surfaces, it cannot go at any other speed other than the speed of light. That's what Maxwell's equations say. The issue comes when you start to move the light clock. If I'm moving with the light clock, I won't notice that anything has changed. Just like we are moving with the Earth right now, we can't discern the motion of the Earth because we're moving with it. A person moving with the light clock will not feel that anything has changed, but somebody watching the light clock will see something rather curious happen. And that is that as the light clock translates, as it moves, the path that's going to be swept out by that photon is going to be a diagonal trajectory as it moves from the bottom mirror to the top mirror back down to the bottom mirror. And if you take a look at that trajectory rather closely, you'll notice something a little troubling, and that is that these diagonal paths is a longer path than the path that light would take if the light clock was stationary, which is straight up and down, the distance just between the two reflective surfaces. Because that distance is longer and this observer watching this light clock move sees the speed of light as being constant, they measure a slower ticking rate for the clock. To them, time appears to be slowing down for the moving clock as it moves along.